Hello, my name is Beth Dixon, and this is lesson 1, homework question number 20. And let's read the problem. Megan told her hired hand, Luke, to gather eggs from the hen house. Luke collected 25 eggs and brought them to Megan. Megan inspected the eggs and complained that 16% of them were broken. How many of the eggs were still good eggs? When you read a problem, you want to be sure that you first understand what the problem is asking and what all is involved in the problem before you begin to think about what math you need to do to solve the problem. Get it out of your head that you'll look at a problem and know whether you're going to add, subtract, multiply, divide, and then what that produces the answer. Get in your head that you want to understand the problem before you begin. So as we start, let's look at what we have. We have a group of eggs that were collected, and we know that that group totals 25. Luke picked up 25 eggs. And out of those 25 eggs, 16% of them were broken. We also know what we're looking for, and that's the question mark. What are we trying to answer? What question do we need to fill in to answer this question? And that's where the question mark is, and that's that last sentence here. How many of them, of the eggs, were still good eggs? So how many of the total number of eggs were still good eggs? So let's kind of summarize that over here. And so what we have is we have two types of eggs. We're going to have good eggs. We're going to have broken eggs. And we're going to have the total eggs. And if I add those two together, I would get the total. And I know that the total is 25. I know that there are a total of 25. So I'm going to have some of these, and they'll add up to be 25. Well, what else do I know? I have this percentage. And I also know that the percentages will add up to be that total. Well, when you have a total, the total number of eggs is 100% of the eggs. Everything is 100%. So the sum total of everything is always 100%. So I know that this is 100% of the eggs. So since that's 100%, what else do I know? Well, I know that 16% of them were broken. 16% of them were broken. So I know that this, and I'm going to erase that little plus sign there that I put, 16% of them were broken. So now, as I look at that 16% of them were broken, that gives me that some number, percentage number, plus 16% would give me 100%. And so those percentages have to add up, just like the numbers over here will add up. So what will that percentage be? And that percentage will be 84%. Now, how did I get that? Well, I just said 16% subtracted from 100. 100 minus 16 is 84. And that gives me 84%. So if 16% of the eggs are bad, that means 84% of them are good. It's the same as saying if there's a 16% chance of rain, then there is an 84% chance of not raining. If we made the numbers a little nicer, it would be the same thing as saying if there's a 20% chance of rain today, there's a 80% chance of not raining today. So we can see that they always have to add up to that 100%. So we've got this, we've got this. Now in the previous problems, I showed you two ways to solve. In this problem, I'm only going to show you one way to solve, and if you need to, you can use the other method to solve it. So in this case, I'm going to solve this. Which way am I going to solve this? I don't know. I think I'm going to solve it with an equation. I had my, this actually is the second time I taped this, and I did it the other way, and there was a reason why I did it with an equation last time, and I can't remember what it is. So what percent of the total is the part? So what percent, and I'm going to use the good eggs, because what am I looking for? Is the part, is the part. We're looking for the number of good eggs. Is the good. And so since that is the good part, is the good, and I'm going to change the is to equals, is good eggs. How many are still good eggs? That percentage is going to be the 84%, so that's going to be 0.84 times the total. So the total number of eggs is 25, and we multiply 0.84 times 25, and I'm just coming over here to my calculator because I can't do that in my head, and I get 21 good eggs. And now I remember, now that I got the answer, that I did do it two different ways, and that's what I intended. But in this case, I'm doing the equation using the 84%. Now I'm going to show you how to use the 16% to get the answer, but I want to do it with the proportions. And so with the proportions, what I'm going to do is say 16 is to 100 the way X is to 25. 25 being the total, so it goes on the bottom, X is the part, and this time I'm going to use the 16. But when I cross multiply, this time I multiply 16 times 25, and I get 400. That's 100x equals 400, and x equals 4. But why do I get 4 here and 21 over here? Well, because in this case, using the 16% is the bad eggs, or the broken eggs. I guess I should put broken and not bad. And so how many broken eggs do I have? Well, I have 4 broken. And remember, what does my question ask? How many of the eggs are still good? So to get this one, I would say 4 are broken. So that means, what do I add? 25 minus 4 would give me 21. So I would get 21 good eggs. And so that would give me 21 good eggs. Let me come over here so you can see the whole thing. And then that concludes the problem. So I did do it two ways. That's what happens when I redo these. I forget what's going on. And as you can tell from the change in shirts, as you go through these, this is a new day. So this is question 20. And that concludes it, doing it both either with an equation or with a proportion. And the equation doesn't have to be done with 84%. The proportion doesn't have to be done with 16. You can use either number. Just remember that when you do the 16%, that you're finding the broken eggs. If you use the 84, you're finding the good eggs. If you find the broken eggs, you have to do an extra step at the end to find the good eggs. If you're using the 84, you do that step at the beginning and do your subtraction at the beginning. So there's always two steps to this, a subtraction and then the percentage problem. You can either do the percentage and then the subtraction, or the subtraction and then the percentage. This concludes question 20. I hope I didn't confuse you too much.